thank you for taking the time to join us on a virtual tour of the Kendeda Building for Innovative Sustainable Design. You're in for a real treat. What you're seeing right here is an online, three-dimensional virtual tour of the Kendeda Building. It allows for people to be anywhere in the world and to visit the building and take a tour of it on their own. Now, there's no substituting being in the building yourself. What we've tried to do in this age of social distancing is to create a solution that's the next best thing. And here it is. It allows you to walk through the building much like Google Maps, and then you can look at the topics. You can walk around the building, and you can then filter what you want to focus on by topic. So let me step back and just tell you a few things about the Kendeda Building. It is built to a standard called the Living Building Challenge. The Living Building Challenge is very much like other green building certification standards in that you have to build to a highly sustainable metric. And we owe all those previous green building standards a great debt of gratitude, because those previous green building standards helped us understand the relationship between buildings, resource consumption, buildings and pollution, and buildings and occupant health. But the Living Building Challenge seeks to go beyond just building better. The Living Building Challenge aims to build regenerative. And what we mean by regenerative is that we want to give back more to the environment. We want to give back more to people than we take. And that's why this building has been constructed to the Living Building Challenge standard, is that we seek to create a fully regenerative building here in the hot, humid Southeast, where folks said that something like this couldn't be built. There's another difference between the Living Building Challenge and other green building certification standards, and that is that we have to prove that we are net positive energy and net positive water through the course of 12 months of operation. So with that, let's step outside. Let's go outside the building to see some of the features that allows us to let me just walk out there. But in the meantime, Danielle, can you unmute so folks can ask a question?
Yes, I will do that right now. Oh, I think the problem is they're not allowed to, or they can't ask questions because they're attending the event as attendee. So what we're going to do, everyone, is if you can drop your questions, I'll be glad to bring that by Shan, please. Thank you so much for doing that.
So we are now outside the building, and you can see that there's this massive solar canopy, and you can see that's the most iconic aspect of the building's design. But what's less obvious is what this building was before, what this place was before the building was constructed. So you see to the left here that we have 7 petals that we have to meet: water, beauty, health and happiness, energy, materials, equity, and place. The reason why they're called petals is that each living building seeks to be like a flower, because flowers also give back more than they take. All the water they need, all the energy they need, all the nutrition they need comes from the place where they are. And then when they leave, There's almost no trace they were ever here except for one thing. And that one thing is seeds, and seeds are life. So we want our buildings to be like flowers, to give back more than they take. So the first was the place, and the site of the Kendeda Building was very much like the place that's across the street. It was a parking lot, and the parking lot also had some vegetation. And what we've replaced that parking lot with is this building. So now it's no longer a parking lot, it's a building. But what's less obvious is that this space, this place, is acting more like the clump of trees over here in the distance than it is a building, because this building is designed to accommodate 90% of an average rainfall on site. So if you look over here on the street, when water falls on this street, it runs off. The rainfall becomes stormwater, and that is a nuisance downstream, which negatively impacts communities, and quite frankly, it impacts all taxpayers, because we have to pay for the infrastructure that then manages that stormwater. The Kendeda Building, 40% of the rain that falls on the site is collected by the solar panels, which also have gutters at the end, and that water is siphoned to the rooftop where additional water is collected, and then that water is taken to an underground cistern, a 50,000 gallon cistern, so the water can be used on site. The remaining water is managed on site through pervious pavers. So you see here, water actually seeps through these pavers and these bioswales. And what the bioswales do is they capture the rainfall and prevent the rainfall from running off. Rather, the rainfall seeps into the ground. So that's how the building is able to function like a forest. 90% of the water that falls on the building stays on site. Another part of the water feature, and now you'll see we've moved from place and really started talking about water almost immediately, and that's because water is very much tied to place. You know, all of these petals are in fact tied to each other. Really hard to separate one of these petals, health and happiness, from another petal, equity, because like the petal of a flower, you really can't separate them. Once you start separating them, the flower falls apart. So going back to water, gray water, which is the water that goes down the sink after you wash your hands or take a shower, that's managed here. This is a constructed wetland. And instead of having your water, your gray water go down the drain, we use nature to manage the gray water. So nature treats it, and then we allow it to seep into the ground. And the other type of water is the icky stuff. The icky stuff, of course, is the poo and pee. And the way that the Kendeda Building manages the poo and the pee is that once you go to the bathroom, your stuff stays here. And a lot of times people are like, that is the most interesting thing about the Kendeda Building. What we're doing now is we're walking into the men's restroom, and then we're going to go into the toilet, and you can see that it's a foam flush toilet. It looks like a conventional toilet, but it's a foam flush, which means that we only use about a tablespoon of water per flush. And then once you leave, your waste basically stays, and the place it goes is directly underneath. So now we are in what we call the composting room. And your bio-waste ends up in one of these 6 digesters. There are actually 6 of them. There's 3 on one side and then 3 on the other side. And in these digesters, natural process breaks up your biosolids into liquid, because that's really what most of your biosolid is, liquid. And then your liquid, obviously, is liquid. And after it's broken down, it gets pumped into one of these 2,000-gallon containers. And in these containers, it's basically become liquid compost. And then when these are full, we have the liquid moved off-site for beneficial reuse. So think about it, ladies and gentlemen. As the building functions as a forest for rainfall, it also functions as a forest for your poo and pee. Because the problem we have with the way that we currently manage it is that we don't treat our bio-waste the same way nature treats our bio-waste. When you go to a forest, you're not constantly stepping on the poo and pee of other animals. It's because it's distributed across the forest. And nature has a chance to break it down and turn it into beneficial nutrients for that site. The building very much does the same. You see, the ingredients are pretty simple. You got pine shavings, it goes in here, your poo and pee lands in there. Eventually we'll have earthworms in there as well. Over years, the biosolids turn to compost, and you can see some of it forming right over here, but most of it's liquid. And because this building does not connect to the sewer, it doesn't concentrate that waste, sending it to a sewer, a central sewer, which quite frankly in our region gets overwhelmed once in a while when there's a major rain event. And so we consider everything that we do with water in our building as something that decreases the burden to infrastructure, decreases burden to downstream communities, and that's an environmental win, an infrastructure win, which is really a taxpayer win, and an equity win, because we're not inundating our downstream communities with our stormwater or, quite frankly, our wastewater. So that is the water story in a nutshell. Another thing that we talk a lot about is energy, and let's do something that is not really possible in an in-person tour, but is possible in a virtual tour, which is go on the roof. So you can see a lot of the things that we're doing with our energy. You know, because solar is such a prominent feature, a lot of folks think that we get to net positive energy through solar. That's not the case. The story of net positive energy actually begins with energy efficiency. And right here you can see 2 things that we've done that are so critically important with energy efficiency. One is we've got triple pane windows. And the triple pane windows really serve as an example of the build quality that goes into this building. This building is 72% more efficient than a conventional building. We get there by building it well. We build it tight, so no air can go in and out unless we wanted to. But because it's so tight, we need to have something called a dedicated outdoor air system, which brings in fresh air from the outside and takes out stale air from the inside. But this dedicated outdoor air system is also part of our energy efficiency solution, because in this system right here, we've got a heat exchange that happens. So in the summertime, when hot, humid air is brought into the building, the cooler, drier air from the inside of the building is allowed to mix with that hotter, humid air, and the humidity is stripped, thereby dropping the temperature and the humidity of the outside air before we push it in. That, by the way, also allows us to collect water in the form of condensate. That water we use for irrigation. That also, by the way, impacts health and happiness, because now what we're doing is we're bringing in fresh outside air, right? So that's one way that we lower the energy impact of the building. Another way is by having heating and cooling that's inside the concrete. You can't see it, but underneath this concrete, we've got radiant heating and cooling, which means that we've got pipes. And underneath the concrete, the pipes will have hot water running through it or cold water, depending on the temperature. And so we take advantage of the thermal mass of concrete. But once you heat concrete, it radiates heat. Once you cool, it radiates coolness. And another thing about the radiating of heat and coolness is that we're really only conditioning air that's a few feet above the average person's head. There's no need for us to condition the air that's up here, right? No one's here. But you'll see we got these big ass fans, and I can call it big ass fan because that's the name of the company that provides these fans. We have so many fans in this building that it really allows the building to remain cool and allows the building to remain comfortable despite the fact that we don't have traditional HVAC. And the last thing I want to touch upon, because we have a limited amount of time, I've talked about how we get to net positive water, talked about how we get to net positive energy. Now I want to talk to you about something that's really special and really people connect to it. It's how we deal with materials. Another thing that we have to do to be net positive is to have net positive materials. And this is a story that really impacts people because I think at the end of the day, folks understand we shouldn't be throwing perfectly good material away. And that's really what we do. Most of the waste that we have in our landfills is waste that comes from construction and demolition. But what we've done here in the Kendeda Building is we've taken things that would have normally been thrown away and incorporated into the Kendeda Building. One of the most compelling stories is the wood that is in these beautiful stairs. This wood comes from Georgia Tech's original, very first building, Georgia Tech Tower. That building was going through renovation, and the original beams would have been thrown away. These are beams that were constructed in the 1880s for that building. That means the trees began their life in the late 1700s or early 1800s. So instead of throwing that away, we repurposed them into this beautiful staircase. The wood for our ramp and for our wooden wall features came from a church that had to be demolished to make way for Georgia Tech's new police station. Instead of throwing all that material away, we were able to salvage some of the material and incorporate it into the building. The wood for this staircase right here is actually the end pieces of the 4x6s in the ceiling. Every one of these 4x6s had remnants from both ends that normally would have been thrown away. Thousands and thousands of pieces that would have been thrown away. Instead, we turned it into this beautiful staircase. The story of reused wood goes on and on. Like, for example, this is a tree that fell down on campus. That bench is a tree that fell down on campus. The countertops, those are also made from trees that fell down on campus. We've incorporated reused materials throughout this building. Reused materials not only allow us to divert waste from landfill, it also has carbon benefits. I mean, in fact, take a look at all the wood we have in this building. That's definitely because of carbon. And we're taking advantage of the fact that if you sustainably grow a tree, that is going to have carbon storage and carbon sequestration in the soil, which is why the building is a mass timber constructed building. We use mass timber beams, whereas a conventional building would have used concrete and steel. We've got trees. We use nail laminated timber for our ceiling because of the carbon benefit, and we used 100% reclaimed brick on the inside and outside, and reclaimed material because we're taking advantage of the embodied carbon. So there is a carbon story here to be told, but a lot of times carbon can be a very difficult conversation to have. So we also reframe it in the context of jobs, because we've got the ability of growing these trees in the state of Georgia. The state of Georgia is already the #1 state in the country for timber, but wouldn't it be great if these mass timber beams were also made in Georgia and then used for Georgia construction projects? And if we had more reclaimed materials that were incorporated into our built environment, that would mean more local labor, because you need local labor to deconstruct a building instead of demolish a building. Then you need local mills and local fabricators to fabricate that reclaimed material into new stair tread, into new wall fixtures, into new stairs, right? And then, of course, that results in an entirely new industry that didn't exist, an industry that we call a salvage industry. So if you take a look at this last image, look at all the carbon solutions that are in this building that also are local drivers of economy. We've got a salvage industry that can be created where local labor deconstructs buildings, where local labor takes a tree that fell down and mills it into this beautiful countertop. Deconstructed materials can become stairs, bathroom tiles. Our bathroom tiles are from slate roofs that would have been thrown away, but were turned into beautiful bathroom tile. And then, of course, I talked to you about the timber industry, where we can sustainably harvest trees. They store carbon in the wood. They can sequester carbon in the soil. They displace the need for imported concrete and steel. They displace the need for importing steel and reduce the amount of concrete that are needed for commercial buildings. So I know I've covered a lot. It's noon. What you're seeing right now, this tour, it's not quite live yet. We're still working through some bugs and adding more content. But please visit us at our website, livingbuilding.gatech.edu. Follow us on YouTube. We're at youtube.com/Kendeda Building. We're on Instagram at Kendeda Building, Twitter, Facebook, LinkedIn at Kendeda Building. Our YouTube site has amazing videos that tell you the story of the Living Building Challenge, take you through a historical process of getting this building built, and have virtual tours. We're going to continuously add new content over the course of weeks and months, and then be on the lookout for this 3D tour going live.
Thank you, Shan, for guided tour. Thank you, Shan, for this wonderful presentation. If you could share the link to the building, I shared one earlier, but I don't know if you have one that has more information that people can really take a look at. I know we had a question regarding that. And also, I want to let everybody know that we have recorded this wonderful tour led by Shan, and it will be posted in the Global Change YouTube and social media networks. Will probably pinpoint you to where you can find it in the coming days. Again, thank you, Shan, for taking the time to do this. If you can just leave us out with this one link, we would hang for a couple of minutes, give you a chance for you to share the link with everybody. And this will be the end of our tour. So thank you again. And if nobody has any questions, I want to wish you all a great day. Thank you for making it to our event earlier today. Thank you for making it to this tour. And I hope everybody has a wonderful rest of your day. Thank you, everyone. Have a good one.
Peace. Thanks, y'all.
Thank you. Bye, everyone.